Hello everyone, in today's short video series, we're going to cover curve sketching using calculus. So the question we're going to cover today is from the 2020 HSC 2-unit paper, and it would be question 16. So the question's asking us to sketch the graph of the curve y equals to negative x cubed plus 3x squared minus 1 by finding the stationary points and the point of inflection. So our first step would be finding the first derivative and second derivative for this question. So our first derivative, y dash, would be minus 3x squared plus 6x. And our second derivative would be minus 6x plus 6. So to find the stationary points, we have to let y dash equal to 0. So let y dash equal to 0 for stationary points, right? So 0 would equal to minus 3x squared plus 6. And we want to find the solutions for x, so we have to factorize minus 3x out. So we get two expressions for x. We get x equals to 0 or x equals to 2, okay? So now that we have our stationary points, we have to determine the nature of these points. And to do that, we're going to use our second derivative by substituting our x values into it. So for x equals 0, our second derivative would be minus 6, 0 plus 6, which gives us 6. And this is greater than 0, so therefore x equals to 0 is a minimum turning point. We have to find the corresponding y value for this point as well by substituting it into our original function. So our corresponding y value would be just negative 1. So therefore, 0, negative 1 is a minimum. We do this for x equals to 2 as well. So for x equals to 2, our second derivative would be negative 6, which is less than 0. So therefore, x equals to 2 is a maximum turning point. And we now have to find the corresponding value for x equals 2 as well, which is just 3. So therefore, the point 2, 3 is a maximum. Okay, so with stationary points out of the way, we have to find the point of inflection now. So how do we do this? Well, we have to let y double dash, or a second derivative, equal to 0 for points of inflection. So 0 would equal to negative 6 plus 6, and we want to factorize that negative 6 out, which gives us x minus 1. So therefore, x equals to 1. So to kind of determine whether this is a point of inflection, we have to prove for concavity. And how do we do that? Well, we have to use our table of values. So let's get our table of values up. So x equals 1 in the middle, and then I'm going to test the points to the left and to the right of x equals to 1. So when x equals to 0, our y double dash would give us 6. When x equals 1, it's obviously 0, and when it's 2, it's minus 6. So because our values go from positive to negative, we know that there is concavity. So since there is concavity, therefore x equals to 1 is a point of inflection. And we also have to find the corresponding y value for this point of inflection. So we're going to substitute it into our original equation, which would give us 1. Okay, so therefore, the point 1, 1 is a point of inflection. So now that we have everything, we want to sketch our graph now. So this is, all it takes is just plotting our points that we just found onto the graph. So we know we have a minimum turning point at 0, negative 1, and we have a maximum turning point at 2, 3. Okay, so all we have to do is connect the two. Oops. This goes down, and then this goes up. And our point of inflection is right in the middle at 1, 1. Okay, so this is how we use differentiation or calculus to sketch curves.